Welcome to this explainer. Listen, if you're currently staring down the barrel of a massive math syllabus, IGCSE, GCSE, or equivalent, and you're just feeling completely overwhelmed by the sheer volume of formulas, theorems, and rules, well, you are exactly in the right place. Today, we're going to attempt the impossible. We are going to completely conquer the entire math syllabus and give you a full summary of math in an 8-minute rapid-fire explainer. By the time we're done here, you won't just have memorized a few neat tricks. No, you'll actually have a complete structural map of how all these mathematical concepts fit together.
Okay, let's just dive right into this. Here's our roadmap so you don't get lost in the weeds. We're splitting the whole universe of math into 4 core pillars: numbers and arithmetic, algebra and functions, geometry and probability and statistics. And finally, we're wrapping up with pillar 5, which is our ultimate exam survival guide. Sound good? Okay, let's start the clock. Act 1, numbers and arithmetic, the foundations.
Let's speed through our first foundational concept here, prime factorization. This is essentially breaking down a massive, clunky number into its absolute purest mathematical DNA. You usually use the latter method for this. You literally just keep dividing your number by prime numbers, 2, 3, 5, 7, until you hit 1. And why does this actually matter? Well, because mastering prime factorization is the absolute backbone for finding things like your least common multiple and highest common factor. It is a guaranteed exam question for sure, and it basically unlocks everything else. Next up, let's categorize these building blocks. Rational numbers. These are quite literally any number that you can express as a nice, clean fraction of 2 whole numbers. So 1/2, 3/4, or even whole numbers like 5, because that's really just 5/1, right? But here is the classic trick examiners absolutely love to pull: recurring decimals. Things like 0.333 repeating forever, those are actually rational too, because they can be written as a fraction, specifically 1/3. Now, on the flip side, we've got irrational numbers. These are the messy, infinite, non-repeating numbers that you just cannot force into a simple fraction. Pi is the classic example here. But what happens when an exam asks you to, say, find an irrational number between 3 and 4? I know, it sounds terrifying, but there's a brilliant hack for this. All you do is convert 3 and 4 into square roots. So 3 is the square root of 9, and 4 is the square root of 16. So to find an irrational number between them, just pick any non-perfect square root between 9 and 16. Root 10, root 11, root 12, boom. Easy, easy points. Okay, when it comes to calculating upper and lower bounds, I want you to remember just one rule: maximize the pizza per person. Seriously, let's talk about limits of accuracy for a second. If you need to calculate the maximum possible value of a fraction, say the upper bound of distance divided by time, think of it exactly like sharing a pizza. To maximize the actual pizza per person, you need the most possible pizza, right? That's your upper bound for the numerator, and you want to divide it by the fewest possible people, which is your lower bound for the denominator. If you just remember maximize the pizza, these bounds questions become incredibly easy. Moving right along to Act 2, algebra and functions, the abstract. Let's look at one of the most notoriously tricky algebra topics out there, completing the square. I'm going to break down this beast of a process into 3 bite-sized survival steps. Step 1, open a single bracket and pop your x inside. Step 2, look at the number next to your x term and literally just cut it in half. Step 3, close the bracket, square it, and then subtract the square of that halved number to balance out the constant. That's the whole shebang. Follow this 3-step formula, and you're going to completely neutralize a very high-level exam question. Now, here is another major trap examiners set: reverse percentages. Say a coat costs $100 after a 25% price increase, and they ask, what was the original price? Please, whatever you do, do not just subtract 25% from 100. That is exactly what they want you to do. Instead, use this column method. Step 1, recognize that the new price is actually 125%. Step 2, set the unknown original price equal to exactly 100%. Step 3, simply cross-multiply your percentage column with your dollar column to find the true original price. It is foolproof, I promise. Act 3, geometry, the physical world. So, keep in mind that 3D geometry is widely considered the hardest topic in the whole syllabus. But before we go 3D, we absolutely have to master the 2D basics. And Pythagoras' theorem is your absolute best friend here. A squared plus b squared equals c squared. The absolutely crucial point is that this single fundamental equation can be rearranged to find literally any missing side of a right-angled triangle. If you need the hypotenuse, C, you add. If you need a shorter side, like A or B, you simply subtract. It's an essential tool you're going to use across almost every geometry question you face.
All right, let's talk vectors, which are essentially just directed lines in space. Let me give you the ultimate hack for vector proofs. When a question asks you to, prove 3 points, P, M, and C, make a straight line. I know it sounds like a nightmare, but all you actually have to do is find the vector from P to M and the vector from M to C. If they're multiples of each other, it means they're pointing in the exact same direction. They're parallel. And because they both share point M, well, they literally must be on the same straight line. It's like a giant puzzle, but that's the cheat code.
Moving into Act 4, Probability and Statistics, the unknown.
To conquer the statistics section, you really just need to master 3 core elements. First, pie charts. You've got to know how to interpret and construct them. Second, histograms. And specifically, you need to understand that it's the area of the bar, not the height, that represents the frequency. That's a huge one. And lastly, you have to master finding your averages, the mean, the median, and the mode, especially when they throw grouped frequency tables at you. Master these 3 elements, and you've pretty much conquered statistics.
Over in probability, I want to give you a massive shortcut. If an exam asks you to find the probability of tossing a coin 4 times and getting heads at least once, calculating all the different combinations of 1 head, 2 heads, 3 heads, and 4 heads, well, that's going to take you forever. Instead, use the at least once rule. Simply find the probability of getting exactly 0 heads, so 4 tails in a row, and subtract that fraction from the number 1. It saves you immense time and practically removes the chance of calculation errors.
And finally, Act 5, the ultimate exam survival guide, the battle plan.
Okay, let's talk about the 2 massive pitfalls that constantly cost students their top grades. First up, doom solving. This is when you panic, shut your brain completely off, just mash numbers into a calculator and accept contextually impossible answers, like writing down a negative probability or calculating that a discounted shirt somehow costs more than its original price. Just don't do it. Take a breath. Then we have ego solving. This is when pride takes over. You think the math is so easy you don't even need to write it down. So you do 0.2 squared in your head, you write down 0.4, and you completely lose the mark because the answer is actually 0.04. Never let pride ruin your grade. So the crucial point here is a rule pulled directly from actual exam marking schemes. You must write down all the stages in your working. Listen, in math exams, you aren't just providing an answer, you are literally proving a legal case to the examiner. Even if your final calculation is a total mess because of a silly typo, showing your steps guarantees you collect those vital method marks along the way. Your working out is your insurance policy. Use it. Finally, where do you go from here? The sources we're explaining point to some incredible platforms for practice. Sites like Save My Exams and StudyMind are absolute gold mines. The secret to potentially doubling your grade isn't just doing full past papers blindly over and over. It's doing topic by topic past papers. Find the specific area from our 4 pillars where you're weakest, say 3D geometry or vectors, and grind out 20 questions in a row on just that topic. Oh, and make absolutely sure you're in the right section for your specific exam board, because IGCSE and GCSE do have slightly different curriculums. Well, there you go. We've built the foundation with numbers, broken down algebra, visualized geometry, and calculated our odds in probability. You have the blueprint now. Are you ready to stop ego solving, start writing down every single step, and officially conquer your math syllabus? Grab those topic by topic papers, apply these pillars, and go crush that exam. Thanks so much for joining me on this 8-minute journey through the mathematical universe here on this explainer. Keep practicing, and we'll catch you next time.